In this lesson, we'll explore abstract classes, which let you define a parent that's intentionally incomplete, a blueprint that subclasses are required to finish. We'll cover the syntax, the rules the exam loves to test, and the polymorphism payoff at the end. Lesson objectives: you'll learn what an abstract class and an abstract method are, write the correct syntax for both, recite the rules about what you can and cannot do with abstract classes, especially that you can't instantiate one, and use an abstract type polymorphically. Each objective lines up with a common exam trap, so let's keep them front of mind. Alright, let's motivate abstract classes with a simple question. What is a generic shape? You can talk about a shape having an area, but you can't actually compute the area without knowing if it's a circle or a square. The parent is too general to instantiate on its own. That's exactly the situation abstract classes are built for. An abstract class is a partial blueprint. It can define some shared behavior, but it leaves certain methods unfinished for the subclasses to complete. And critically, you cannot create an object of an abstract class directly with new. It exists to be extended, not instantiated. So whenever you have a concept that's real as a category but meaningless as a standalone object, you're looking at a candidate for an abstract class. Alright, let's look at the syntax, because there are two pieces. First, you make the class itself with the keyword abstract. Second, inside it, you can declare abstract methods, which have a signature but no body, just a semicolon where the curly braces would be. In the example, shape is abstract and declares an abstract area method with no implementation. An abstract method is essentially a promise. Any concrete subclass must provide a real body for it. Notice that an abstract class can also have normal full implemented methods and fields too. It's a mix of finished and unfinished parts. That blend is the whole point. Share what's common and force subclasses to fill in what's specific. Alright, here are the rules that the exam tests, so let's be precise. You cannot create an instance of an abstract class with new. That's an immediate compiler and a favorite exam trap. An abstract class can have constructors, fields, and fully written methods, even though you can't instantiate it directly. Subclasses call those constructors via super. If a class contains even one abstract method, the class itself must be declared abstract. Let me say it again. If a class contains even one abstract method, the class itself must be declared abstract. And when a concrete subclass extends an abstract class, it must implement every abstract method. It must implement every abstract method if you are extending an abstract class. Otherwise, that subclass also has to be abstract. So when the chain continues until some class finally fills in all the blanks, the chain can basically continues until some class finally fills in all the blanks. Watch especially for code that tries to say new on an abstract type. That's the trap that they set most often. So why even go all of this trouble? Because an abstract class gives you a polymorphic type to program against. Even though you can't make a plain shape, you can absolutely have a shape variable or a shape array that holds circles and rectangles. Then you can loop and call area on each, and dynamic dispatch runs the subclass version. It's the same polymorphism payoff from the last lesson, but now the parent guarantees through its abstract method that every subclass truly provides an area. The abstract class both promises the method exists and forbids meaningless generic objects. That combination, a shared type plus an enforced contract, is exactly why abstract classes are so useful in real designs. Alright, pause the video and try this question. Alright, which line is illegal? Line 2 tries to instantiate the abstract class directly with the new shape. That is always a compile error. Line 1 is fine. A shape reference can hold a circle object. Line 3 builds a concrete circle. Line 4 calls area through a shape reference. Area is declared in shape, so it compiles and dispatch runs circles version. The answer is B. Let me reinforce this for you. You can reference an abstract type, but you can never new it. I almost said mu. All right, try this question, pause the video, and we'll be back. All right, will triangle compile? A concrete subclass must override all inherited abstract methods. Triangle overrides area, but leaves perimeter abstract. So as written, it does not compile. To fix it, either override perimeter 2 or declare triangle itself abstract. The answer is B. The distractor here is D. A missing constructor is not the problem here. Java would supply default if the parent allowed it. Alright, key takeaways for abstract classes. An abstract class is a partial blueprint you cannot instantiate directly. It can mix finished methods and fields with abstract methods that have no body. Any concrete subclass must implement every abstract method, and abstract types give you polymorphism while guaranteeing the methods exist. Keep the no instantiation Keep the no instantiation rule especially sharp, since that's the most common trap. Review the practice problems, and I think you'll be fine, guys. Well done.